Hello students, welcome to Pi Academy, the place for mathematics and science. Dear students, in yesterday's class, we finished the very first chapter in mathematics, that is number systems, right? Yes. Now, let's go for continue to discuss the chapter motion and let us try to finish up it because we are in the last part of this chapter and you all know that we were solving some of the problems which are given in exercise, right? Only one problem was completed. Now I have taken the second one. Let's go for this. And before that, do remember this is 9th period of this chapter. Yes. Let me read the question. Listen carefully. Here, Joseph jogs from one end A to the other end B of a straight 300-meter road in 2 minutes 30 seconds, and then he turns around and jogs 100 meters back to the point C in another 1 minute. If so, what are Joseph's average speeds and average velocities in jogging? There are two different cases. One is from A to B and another one from A to C. Clear? Now, I hope that you have understood the statement. Once I make you to understand, look here. He moves from one end A to the other end B of a straight 300-meter road in 2 minutes 30 seconds. I draw a straight line which represents the road. It is the end A and this is end B. What is the length of this road? Yes, you are right. It is 300 meters. I am marking it. Joseph, he moves from A to B, but how much time it takes? It takes 2 minutes 30 seconds to move from A to B. Then after that, he comes back. That is, he started moving from B to A, but he moves for just 100 meters. And the final position is to be considered as C. Clear? Okay. Now let's go for finding the solution for this. Here you are going to find out average speeds and average velocities. To find out average speed, you must know the total distance traveled and total time taken. To find out average velocities, total displacement of a body and total time taken, right? Yes. First one, it is from A to B. From A to B. So let us go for taking distance as well as displacement. What is the distance traveled by Joseph from A to B? Yes, it is 300 meters. What about his displacement? Displacement is also 300 meters. The reason is initial position and he is A, final position is B. The direct distance from A to B is 300 meters. And you also know that he has taken 2 minutes 30 seconds to move from A to B. Here are right. Time. How much? 2 minutes. 2 minutes 30 seconds. Let us convert this into one standard unit. Here these distance and displacement are in meter. So it should be, time should be in seconds. 2 minutes. You all know that 1 minute equal to how many seconds? 60 seconds. 2 minutes, it is 120 seconds plus 30 seconds. Altogether it will be 150 seconds. Clear? With this information, you are going to find out average speed and average velocity. Here are right. Average speed. Average speed. How do you go for finding average speed? Average speed is total distance by total time taken. Total distance is, it is D. Total time taken is T. This is equal to, distance is 300 and time is 150. It is 1s or 2s. It is 2 meters per second. This is average speed of Joseph from A to B. Similarly, let's go for taking average velocity. Then how do you find out average velocity? This is also very simple. Total displacement by total time taken. What is the total displacement? It is S. Total time taken T, where S is, that is also 300. Then time, it is 150 seconds. Ones are, twos are, 2 meters per second. See that average speed and velocity, both are same. Now let's move on to second case. What is that second case? It is, he moves from A to C. From A to C. Now, then what is the distance traveled? Look here. Just observe. First he moves from A to B, then he comes back to C. A to B 300, B to C 100. So 300 plus 100, 400, right? I go for writing the distance traveled by Joseph from A to C. Here I'll write it is AB plus BC. For the sake of understanding, I am writing in detail. AB plus BC, where AB is 300, BC is 100, altogether it is 400 meter. Got it? Then displacement. Dear students, you know that displacement is nothing but the least distance or the direct distance between the initial position and final position of a body. Here, what is the initial position of Joseph? It is A. Final position? It is C. From A to C, how much? It will be 200, because see that A to B 300 minus 100, it will be 200. Here I'll write S is, it is AC. AC is nothing but AB minus BC. It is 300 minus 100. It is equal to 200 meter. Then what is the time taken? Time taken by him. Observe here. Look here. He turns around and jogs 100 meters back to point C in another 1 minute. Got it? We know the time taken by him from A to B, 2 minutes 30 seconds. Then B to C, to cover this 100 meters, he has taken 1 more minute. So again, for the sake of understanding, I go for writing the time like this. 2 minutes plus 30 seconds plus again 1 minute, right? Here I write 1 minute. It is equal to 2 minutes. It is 120 seconds plus 30 seconds, 1 minute, 60 seconds. Altogether, 120 plus 60, 180 plus 30, 210 seconds. Got it? We have come to know the total distance, total displacement, as well as the total time taken by Joseph from A to C. A to C means don't consider directly from here to here. See, he has moved from A to B, then he has come back to C. Next. Here, I'll find out first average speed. Average speed is total distance by total time taken. D by T. What is the D in this case? It is 400. What about the time taken? It is 210. 0, 0. Get cancelled. 40 by 21. Here, let us divide this. 40 by 21. 21 ones are 21. Here, 9. 3 minus 2. 1. 19. So, again put decimal. Take 0. 190. Then 21 how much are? Can we go for taking 9? Yes. 9 ones are 9. Then 9 twos are 18. It will be 1. So, take 0. Here again it will be 0. 100. It is 4s are. So, approximately we can write 1.9 meter per second. Got it? Next. We have to find out average velocity, where average velocity is total displacement by total time taken. What about the total displacement? It is 200. Time taken 210. 0, 0 again get cancelled. 20 by 21. Here I am dividing this. 20. It should be divided by 21. 20 is not divisible, so that to decimal take 0. 200. Again take 9s are. How much? It is 9 1s are 9, 9 2s are 18. 189. It will be 11. Then take 1 0. 21. 5s are 105. 0.95. 0.95 meter per second. Got it? So we can write the conclusion. Observe. Average speed of Joseph from A to B is 2 meter per second. Average velocity of Joseph from again A to B, it is 2 meter per second. Then average speed of Joseph from A to C is 1.9 meter per second. Again, average velocity from A to C, it is 0.95 meter per second. I hope that you have understood. Now please pause the video and copy from there to here quickly. Yes, dear students, here we have another very interesting statement. Let's go through that. That has been given in question number 3. It is, Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. Got it? He has calculated that. Average speed will be 20 km per hour. On his return trip along the same route, there is less traffic. Obviously, when less traffic is there, vehicles, they will move faster. And the average speed is 30 km per hour. Then what is the average speed for Abdul's trip? See, here how many situations are there? 2 situations. What are those? One is forward trip and second one is return trip. Is it not? If he has moved along a straight line, then we would have considered the average velocity, right? There we have a formula u plus v by 2, where u is initial velocity and v is final velocity. But here they have asked average speed. We have a formula to find out average speed. Could you tell what is that? It is average speed is equal to total distance by total time taken. Total distance. Here there are 2 situations, right? Hence we can write this as d1 plus d2. Total time taken. Obviously time will be different. I go for taking t1 plus t2. Do you know both of these? Let us check. Let us write the data. Observe. Abdul, while driving to the school, computes the average speed for his trip to be 20 km per hour. Then on his return trip along the same route, there is less traffic and average speed is 30 km per hour. Let's go for writing that. Look here. Average speed in forward trip, call it as, it is 20 km per hour. Then again, average speed in return trip, how much it is? It is 30 km per hour. Okay. Now, what is the distance he has covered? Distance covered in forward trip, it is unknown. Let us call this as x kilometer. Here I write. Distance traveled in forward trip, it is called as d1. And this is equal to x kilometer as it is unknown. Let us go for finding again distance traveled in return trip. How much? You may call it as d2. That is also same distance, x kilometer. See that we got d1 and d2. Next we want t1 and t2. Then time taken in forward trip. Here I'll go for calculation. Here we all know that V is equal to d by t. Speed is equal to distance by time taken. Then what about time? T is equal to distance by speed, that is d by V. Here I'll go for writing that. That is time taken in forward trip. It is equal, call it as T1 is equal to d1 by V1. What is d1? d1 is x by V1, forward trip. It is 20. For your reference, you can write this as V1 and this as V2. Next, again, time taken in return trip. How much? It is T2. It is d2 by V2. d2 is again x, V2 is 30. X by 30 R. Next, let's go for taking substitution. As these are in fraction, let us go for finding T1 plus T2 directly. Then it will be easier. T1 plus T2, this is equal to T1 is x by 20. T2 is x by 30. This is equal to, what is the LCM of these two? It will be 60, right? LCM of 20 and 30, you can find it out. 20, 30. It is 10 2s are 3s are. 2 3s are 6, 6 10s are 60. Then multiply 60 with first term. 20 3s are 3 into x, 3x. Here multiply 60 with second term. 30 2s are 2 into x, 2x. It is equal to 5x by 60. This is equal to, it is 5 1s are 5 12s are. So x by 12 r. Clear? Next, average speed, total distance by total time taken in two cases. What is the distance covered in first forward trip? X. And return trip, that is also x kilometer. T1 plus T2 you can substitute directly. It is x by 12, which is equal to, this is 2x into 12 by x. Get cancelled. 12 2s are 24 kilometer per hour. Clear? So you can write the conclusion as the average speed for Abdul's trip is 24 kilometer per hour. Here I will write. Therefore, the average speed of Abdul's trip is 24 kilometer per hour. So, before copying, you have to go through that thoroughly, understand. Okay, then you can pause the video, start writing from there to here. Copy this. Dear students, now let's move on to the fourth question. Observe this. A motorboat starting from rest. A motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3.0 meter per second square for 8 seconds. How far does the boat travel during this time? I hope that you have understood. Very simple statement. Here, let's go for writing data. Once we shall move on to the statement to write the data. A motorboat starting from rest, if it has started from rest, when it was at rest, what was its speed? Yes, it was 0. Then what do you call that speed? It is initial speed or initial velocity. I take that as u equal to 0 meter per second. And it accelerates in a straight line at a constant rate of 3 meter per second square. What does it mean? Here it is changing its speed continuously, and it gains the rate of change of velocity is nothing but acceleration. That acceleration is 3 meter per second square. Here I will write A equal to 3 meter per second square. Then for 8 seconds, time taken t is equal to 8 seconds. Now the question is, how far does the boat travel during this time? In 8 seconds, with this acceleration, how much distance it will cover? Let's go for taking this as yes. Okay. Now, calculation. How do you go for calculating this? You can go for using the equations of motion, because here we have S, T, A and U. 3 equations of motion. Once you just recall them, V equal to U plus AT, this is first one. S equal to UT plus half AT square, second one. Then 2AS equal to V square minus U square. Which of these is suitable for solving this one? Look here, UATS. UAT, yes is not there, don't want. UATS, this is suitable. UAT is not there, not suitable. Let's go for taking the equation of motion. S equal to UT plus half AT square. On what basis it has been written? From equation of motion. Now, let us go for taking substitution. What is U? It is 0. Time 8 plus half into where A is 3 and time is 8 whole square. This is equal to 0 into 8. 0 into anything is 0. Here I will write it directly. Half into 3 into 8 square. 64. 1s are, 3s are, 2s are. Now 32 3s are, 33s are 90, 2 3s are 6. 90 plus 6, 96. S equal to 96 meter. Conclusion you can write. Therefore, the motor boat covers a distance of 96 meter in 8 seconds. Here I write. Therefore, the distance travelled by the motor boat is 96 meter. Here. Okay. Next we have another important statement. Along with that, you have to copy this one, because after when I am explaining, I need this space also. Yes, copy from there to here. Then after that, copy even 5th question also quickly. Dear students, you have already copied this and even you might have read also. But once you read with me, yes, 5th one is given like this. A driver of a car traveling at 52 km per hour applies the brake and accelerates uniformly in the opposite direction. That means the speed will be increasing or decreasing? Yes, decreasing. Whether it moves with positive acceleration or negative acceleration, it is negative acceleration, right? Next, the car stops in 5 seconds. After the application of brake, the car stops after 5 seconds. Then another driver going at 34 km per hour in another car applies his brake slowly and stops in. It takes more time, that is 10 seconds. Now the question, sub-question is like this. On the same graph paper, plot the speed versus time graph. Nothing but velocity time graph for the 2 cars. After that, which of the 2 cars travelled farther after the brakes were applied? You have to find out the distance covered by the first car. Then after the brakes were applied, similarly the distance covered by the second car. These are to be found out. Okay, now what is the first question? It is, we have to draw the graph, velocity time graph. In both the cases, graph should be drawn in one only. And before that, just let me write the data. Here it has been given. A driver of a car traveling at a 54 km applies the brakes and accelerates uniformly in the opposite direction. The car stops in 5 seconds. I'll take the first driver. first driver and is driving a car with a speed of 52 km/h. Next, and the time taken to stop, it is 5 seconds. Then after, when it stops, then final velocity will be 0, u equal to 0. Next, I go for taking second driver. He is driving another car and is driving with a speed of 34 km/h. So this is initial velocity. Then, and he applies the brake, car comes to rest in 10 seconds. So t is equal to 10 seconds. When it comes to rest, the final velocity will be 0, v equal to 0. Let's go for drawing the graph. Here they have asked velocity time graph. Look here. This is. Here v is to be taken along y-axis and t is to be taken, time is to be taken along x-axis. Then look here, we have to write the scale. He is traveling with a speed of 52 km/h and second driver 34 km/h. Then how do you go for taking? You can take 1 centimeter equal to 10 km/h. So it is 10 km/h and time has been given in seconds. See here, we are not focusing more on the units. Later in calculation, we will focus. Observe it. Here this will be 10, next 20, 30, 40, 50, 60 because the highest speed is 52 km/h. Then what about along x-axis? Total time is in first case 5 seconds, second case 10 seconds. I go for taking every 1 centimeter equal to 1 second. So then 1, 2, 3, 4 up to 10. Clear? But how to draw the graph? In graph sheet I will show that. Observe it. Here along x-axis I have taken time and scale 1 centimeter equal to 1 second. See that 1 second, 2, 3, 4, 5, 6, 7 and so on. It has been continued. Then in y-axis I have taken the velocity, the speed. Here I have taken every 2 centimeter as 10 km/h. Km/h. 10, 20, 30, 40, 50, 60. I could have taken just 1 centimeter equal to 10. It would have been smaller. So that is why for our convenience I have taken 2 centimeter equal to 10 km/h. Now first driver, he is driving the car with a speed of 52. Look here. Here 52, 60, total 20 divisions are there. So 2 divisions together make 1. So 51, 52. After 4 division. Now from here, then he stops. The car comes to rest after 5 seconds. So from here to here, line is drawn. Okay. Then the second car, it was traveling with a speed of 34 km/h. See that 30. 2 divisions is 1 km/h. So all total after 8 divisions I have marked. This is 34. Then the second car comes to rest after 10 seconds. Now, look here. Now I am going to show the direction. But because the speed will go on decreasing, finally it comes to rest in first car also. Clear? This is the graph. You have to draw the graph in this way. And please write the scale. What you write? Here in x-axis, 1 centimeter is equal to 1 second. And y-axis, here I have written 2 centimeter equal to 10 km/h. Clear? Okay, now let's go for answering the second sub-question. We have drawn the graph. Second sub-question is, which of the 2 cars traveled farther? Means, which of the 2 cars covered more distance after the brakes were applied? Right? That should be found out. Look here, this is VT graph. In case of VT graph, how do you go for finding the distance? Dear students, we have already learned that in case of VT graph, the area under VT graph is what? It is displacement, right? So here also you can go for finding the area. How? Let me show you that. Just you have to observe this graph again. Look here. First car. I marked the point A. Observe here. We have to find out the distance covered by the car. Hence, I should consider the triangle ABC. Area of triangle ABC, it is half into base into height. Base BC, height, it is AB. Clear? What is the base? How much? It is 5 seconds. Then height, it is 52 km per hour. Understood? Now I'll go for calculating. Observe. Here, distance covered by the first car. First car, it can be written as, it is area of ABC. D is equal to area of ABC. You can write the reason in bracket. What do you write? Because the area under VT graph is displacement. Next, area of ABC is half into base into height. Base BC, height AB. What was the base? It is 5 seconds, right? Then AB, we consider this height. It is 54 km per hour. 54 km per hour. This time I am writing with unit. This is equal to half into 5 seconds into, let us convert this into meter per second. 54 km per hour can be written as 5 by 18 meter per second. Here second and second get cancelled, only meter will remain. Now, this is equal to, now you can go for cancelling. 2 1s are 2 27s are 5 5s are 25 into 27 by 18. Let's go for multiplying this. 25 7s are 175. 25 2s are 50. 50 plus 17, 67 divided by 18. Clear? Now, or else you can make this calculation as simple by cancellation also. See that 9 3s are 27, 9 2s are. Now 25 3s are, it is 75 by 2. The calculation will be much easier. It is 2 3s are 6, 1 will remain 15. 2 7s are 14, 1 will remain 10. Then 5s are 37.5 meter. This is the distance covered by the first car. Now let us go for distance covered by second car. Distance covered by second car. Then to find out that, again we should consider distance is equal to area of, observe this graph. Here I have taken the second, here I am showing the graph of second car, motion of the second car. You can notice that PBQ, this area should be considered. Half into base is BQ, height is PB. What is the base? How much it is? BQ is total 10 and this is height is 34 km per hour. Understood? Half into BQ into BP. Here I will write area of PBQ. Area of PBQ. This is equal to half into, then here base, it is BQ. Height, this is PB. Now let me go for writing half into where BQ is 10 seconds, okay, into PB is 34 km per hour. 34 km per hour. Now, this can be written as half into 10 seconds into 34 km per hour is there. It is 34 into 5 by 18 meter per second. Second get cancelled. Again meter will remain. Now 2 ones are 2 fives are. It is equal to. Now again you can go for cancelling here. 2 nines are 2 17s are. Now 17 into 5 fives are 25 by 9. This is equal to 17 into 25. 25 sevens are. 25 sevens are 175, 17 is the carry. 25 ones are 25 plus 17, 35, 42, 425 by 9. This is equal to, cancel this. 9, 42. You can go for cancelling like this by dividing. 425 should be divided by 9. 9 fours are 36, 6 will remain 65. 9 sevens are 63, 2 will remain, put decimal, take 0. 9 twos are 18, 2 will remain. Again, to 47.2 meter. This is the distance covered by the second car. Now, let's go for answering. Which of the two cars traveled farther, covered more distance after the brakes were applied? Which one? First car has covered 37.5 meters. Second car has covered 47.2. Hence, you can conclude that. Here, first I will go for comparing. 47.2 meter is greater than 37.5 meter. Therefore, the second car covers more distance after the brakes were applied. After the brakes were applied. Hope that you have understood this. Now, dear students, please follow my instruction. You have already copied this statement. Then here you will write data regarding initial velocity, final velocity and time with respect to first driver. Then with respect to second driver, you will write this information. After writing this much, then you will go for drawing the graph. Okay. After drawing the graph, then you go for writing the distance covered by the first car. If you want, you can write the reason. What is the reason? The area under VT graph is displacement. Then you will write up here. Next, after this, you come to this part. Distance covered by second car. After all this, you will go for comparing the distance covered by both the cars. And you will write the conclusion. Therefore, the second car covers more distance after the brakes were applied. Clear? So you have to write the whole thing with patience. Now pause the video and copy from here to there. Again you come back to here. Right. Dear students, let's move on to sixth one. Figure 8.11 shows the distance time graph. What is that figure? Let me show you that. Here we have. Observe. You should also copy this one. This is as it is given in the textbook only. I have drawn it. Observe this carefully. Here we have along x-axis time has been taken in r. Along y-axis distance has been taken in kilometer. And these are the straight line which represents dt graph of three objects. Okay. Now go through that. That figure, it shows the distance time graph of three objects A, B and C. Study the graph and answer the following question. The questions are very simple. See, which of the three is traveling fastest? This is first question. And second question, are all the three ever at the same point on the road? Next, third one, how far has C traveled when B passes A? And fourth one, how far has B traveled by the time it passes C? This is the given question. The students, you have to copy this and try to answer these questions by observing this graph. Okay? And by tomorrow you just get ready with the answer. Again, I will go for explaining in tomorrow's class. Okay? So before concluding the class, let me remind you one thing. Whatever we have covered, please practice them today itself. Don't keep anything pending. And tomorrow certainly we are going to finish this chapter. And for Sunday's test, get ready. Okay? So with this, let us stop the class. Thank you.